Hi, my name is Kevin. I'm the CEO and co-founder of Pyro-E. Batteries are expensive, but do you know it represents the most expensive power in the world today? I'm presenting our NASA technology as a solution to reduce the cost of water for homes, schools, hospitals, and buildings. The need for power for remote monitoring is especially acute for water because our infrastructure is old, it's massive, and it's prone to leak. It's expensive. Not only that, the response to a fix is extremely slow. Typically, it takes 3 hours for a water utility crew to fix a pipe burst. As I mentioned, the one-time use battery is expensive. However, it's avoided by engineers in the water industry because it degrades over time. It tends to explode in hot places, and it's difficult to recycle and dispose of. In response, our unique solution is a battery replacement technology that lasts 1,000 times longer through energy harvesting. It is stable under high temperatures of chemicals, oil, and gas, and it will not lose power over time. And it can also be recycled at the end of life. What is good about the comparison is that the hardest part is to know where to use our device. And we've done our homework, and the story is clear. It's water. The magic is that we convert fluid pressure into electricity, and our customers love our product because it responds to low pressure forces, it does not require fluid contact, and it could operate without maintenance. Next slide is. So as a replacement technology to batteries, as mentioned, it lasts 1,000 times longer than individual batteries over 10 years, and it's 100 times less expensive, mainly because of labor of excavating products that are underneath the ground. 4 years ago, I co-founded Pyro-E on my kitchen stove and have since attracted multiple technology awards, received $1.3 million in non-dilutive financing, filed 3 patents, and obtained 5,500 pre-orders. Our business model is simple. We work with existing water equipment manufacturers to make their product more competitive. The fluid control market is $13 billion annually, and we're 100 times cheaper than the next best thing. However, expensive power and water is not just a problem. It is a problem we're solving because we help customers become more competitive with their products. To reach our customers, we already contain pre-orders from various markets, including water OEMs. And our next move is into water IoT to power smart devices for consumers. If we're not required by then, we intend to piggyback on that success and work with industry giants to improve their offerings to utility partners. To be fair, our customer acquisition cost is high, but we build loyalty with early access to new and improved versions of our product. We're currently cash flow positive with 5,500 pre-orders in the book. By servicing these, we're about 35% of our sales targets through 2023. However, currently we need help cutting costs and automate in-house production. For that, the size of the Series A round is 1.5 million, and the investment vehicle is a convertible debt. To sweeten the deal, our investment will be double matched with grant money, about 60% of which will go towards sales and marketing to grow our business. Again, my name is Kevin. I have a PhD in mechanical engineering. My co-founder and I both have technical backgrounds and are capable of developing the technology in-house. As mentioned, the technology originated from NASA to power satellites in orbit, and with the concept of our technology published in 2 world-leading journals for dissemination. Since our company inception and 4 months into product launch, I'm proud to have achieved product market fit with water stakeholders. We have demonstrated traction with unique and patented product. We're positioned to grow and repeat customers through product iterations. And lastly, we really believe in our technology because energy harvesting from mechanical forces is currently sitting where PV was 50 years ago, and we intend to capture a piece of the future today. Thank you.
Thank you so much, Kevin.
All right.
Great. Are there some questions for Kevin?
Don't forget that chat box.
I think, Kevin, maybe you could expand a little bit on the fact that this is a platform I mean, this is just the first application. The water is just the first application, right? It could be used for lots of other things. There's a
Right, yeah, right. So we're starting with water just because the current technology landscape in water is pretty stale. We're introducing a very novel technology for this field, and we're getting very good traction with there's a response from large customers, and we'll continue with that success.
great. There's a question from Keith Larson. How does the technology actually convert pressure to electricity?
Yes, it works like a car's pressure booster, brake booster. So it converts very small pressures down to 2 psi's, pounds per square inch, plus or minus, and we amplify that force into a piezoelectric element. So it's like the smart material conversion process that responds to apply stress and to produce electricity from that. And the goal is to power small devices currently. So for data and measurements and actuation.
There's a question from William Eisenman. Where is the AI related to this product? I
A
believe
lot of our customers already have a plan for using data to automate monitoring and processes. So right now we definitely just provide the hardware solution for obtaining that data for them. Obviously, there's always benefit for using that data for business development, but currently our plan is to supply our device for their data collection technology.
Okay.
Yeah.
There's another question from Taylor. Is the technology entirely solid state? What is the product's useful life? And are there specific maintenance considerations in the field?
Yes, it is entirely solid state. There are no moving parts. Well, things are moving, but it's not based on sliding components, not like a car engine or it's direct conversion from the applied stress. It's the expected life from manufacturers is 10 billion cycles. So these things are made to actuate currently in various technologies like the injection, fuel injector in the car. So they're meant to actuate and respond to stress and apply stress. And we adapting it to produce electricity instead of that into a battery. Overall, the system is highly optimized through simulation and software analysis. So we are expecting the life to last longer than the electronics on board, which is about 8-10 years. So we want to make the whole system last above 10 years.
So it lasts 10 years? 8 to 10 years?
Yeah, right.
So there's no maintenance really for it?
Right. So ideally, there shouldn't be any maintenance issues, at least with the power system itself. Right.
Okay, so this is a NASA technology. What is the focus of the patents, the NASA patents?
What is it?
What is the focus of the NASA patents?
So the patents from NASA is to actually harvest vibrational energy for satellite power. So things vibrate in space just from propulsion and various sources, and we use it as a form to generate low power for sensing and communication in space. And we're adapting that for low frequency, high force operations. So instead of vibration, we have a more impact-based energy harvesting. And this is pretty new in terms of harvesting.
It's piezoelectric.
Yeah.
Okay, so it's a piezoelectric, and you changed it, so you probably couldn't do another patent on it. Paul Leak is asking, have you approached any strategic industrial valve or instrumentation companies like Fisher or Honeywell?
Yes, we're starting small. We're not small, but these are less technology savvy companies. despite their size. So we are speaking with a couple large water equipment makers who are making, dumb water equipment such as water heaters or valves, and we want to help with the automation and transformation with a staying powered solution. So yes, we're trying to collaborate with larger partners all the time, and our response has been pretty positive with our introductions.
So another question is, what is the electricity used for? To help with the water infrastructure? They don't understand how does the energy, electricity, how does it, what is it used for in the water?
Yeah, so for example, in the South, many backflow preventers, they fail over time. And there are a couple types of backflow valves. One is battery powered, the other is, and a lot of these times they're put outside of the building, and solar panels that collect dust, and then, for example, when batteries fail. So a lot of these backflow preventers are failing outside, and that's causing a problem. Every hospital has 2 backflow preventers, for example, in the basement, that's for preventing such things from happening. So it is critical in certain buildings and industries where backflow is limited. So the whole thing about supplying power perpetually for these devices is to allow it to be, ready for data acquisition or sudden backflow prevention or sudden shutdown of.
So Kevin, it's controlling the valves?
Yes.
Okay. So so I think Mike Ryan asked the question, what is the Pyro-E patents focused on? It's a piezoelectric energy, the special kind of taking the special means by which you're generating energy through movement, essentially. But Kevin has actually changed the foundational components of the patent and actually made it better, a lot better. Sorry, I just wanted to. So there's another question I think I missed. No, I didn't. Okay, let's see. Question, just to clarify, this product is to power the sensors that water companies use to monitor the sensors?
Yeah, it is used for any sensor or actuator valves that need power remotely. So a lot of these valves, they use batteries currently, and if they run out, there's no backup power, right? Battery is the backup. So what we're providing is a more reliable form of power for these devices. And this goes from water to oil and gas to chemical wastewater plants that use similar technologies.
Is this paired with a native control mechanism? Are there parasitic loss and or EMF considerations when implemented in a broad array?
It doesn't. So our electronics, which is the highest frequency part of the technology, our electronics for converting piezoelectric energy storage, is operates in the sub-kilohertz range. So there's no influence in that in we checked with CD and L3 for that, and so and the goal is to deploy this in mass, and trying to employ intelligence into current infrastructure.
Taylor, did Kevin answer your question? It doesn't collect bacteria. I mean, I think that the way you're designing it, it's got that surface that doesn't get bacteria on it, right?
Right. So we're totally separated from the fluid. So unlike other energy harvesting devices out there, which require a constant flow of either the fluid or the gas, we are totally separated from the fluid. So
oh, it's Taylor.
Yes.
Can we unmute? I'll unmute Taylor. He wants to be unmuted. Sorry about that, Taylor. Okay, you're. I clicked on it. Where's it again?
Right. So
Carol, you should be able to talk now.
did I answer that question? So we designed this to be able to convert energy without any fluid contact, and and it operates at fairly high temperature as well. So you could have some thermal communication, heat transfer from the fluid to the device, and it still work.
Taylor, did you want to say anything? Because you're unmuted. There's just one more question here. Is there any possibilities for external EMF failures as a result of your pulses?
External EMF failures? I'm not sure if that's still the external.
Sorry, you're breaking up. Could you speak a little bit louder, maybe?
Yeah, I'm not sure what the external part is. Are you talking about the radio that's attached to the device as the one being impacted, or?
Okay. Maybe you can get back to him. Why don't you connect with him offline? And I think that we could, thank you very much, Kevin. Like if there's,
Sure.
oh, like a terrorist attack. That's what he's asking. Is there any possibility
Oh,
EMP?
our basic in electronics has no MCU, so it's analog devices, so nothing digital. So I would think impact is and we want to service that tough industry. Power plants, high value energy.